Hello, hello, hello. Good evening, my warriors. It's time to start the revision of modern physics. So sorry for the delay, and welcome to the sprint series with me, your physics master teacher at Vedantu, going live. Hello, everyone. Hello, Tamil. Hi, Ramya. Hi, Sandeep, Rishabh, Anay, Reddy. Welcome aboard. And today's session is aimed at all the students who want to solve and revise modern physics in this one-shot problem solving session with revision of important concepts and formulas. All of this in today's session. Hi Karthik, hi Pranesh, hi Blessy, hi Devi, hello Tushar. So if you are a repeater, you should be basically filling up all your gaps. Study all the chapters. Don't look at important and chapters which you can skip. You should do everything, and just 2-3 months before the exam, start solving lots and lots of mock tests. That's what you should do for physics. Okay, so those of you who do not know me, my name is Shreyas, and I have done my graduation from NIT Nagpur. I did my research from IIT Bombay. I've been training kids for more than a decade now, and many of my students have got awesome super duper ranks in JEE, and just like you guys are going to make me proud this year. Okay, obviously semiconductor is not included, Pranesh. This includes atomic structure. This will also include X-rays. It will also include photoelectric effect, Broglie wavelength, all of that, and then nuclear physics. Okay, cool. So, what is the most important and expected question all about? So it's all about what we feel have been asked in the recent years. Based on those concepts, I have collected some beautiful questions, which are, very much related to the previous year questions. And these are important things which you must do. Okay. Is that clear? Okay. So let's begin. And in the recent years, do you know that this chapter has so much of importance that you can easily score around 12 to 20 marks just from the modern physics section? I'll tell you how. In physics, you have atomic structure, de Broglie wavelength, etc., photoelectric effect. It's also there in chemistry. So these same topics come in chemistry. So if you look at it as a whole, including X-rays and nuclear physics, there could be at least 3 to 5 questions in the entire paper. That means 12 marks to 20 marks. Now 20 marks is a huge number because it can change your rank by many thousands, and it can decide whether you are going to get 99 plus or 99 below. So that's how you're going to accumulate the marks. So do not neglect this chapter. Is that okay? So let's begin. And ray optics, it will be generally 1 to maximum 2 questions. That's 4 to 8 marks at least. And yes, have you liked and subscribed the video and the channel? If you haven't, do that. It means a lot to me. And I also need to make this very important announcement about all the students of 10th standard who have made us proud by getting and qualifying the NTSE Stage 2 examination. They, in fact, 12.5% of the students who cleared the examination are from Vedantu. Out of all the students who were in Vedantu in the 10th grade, there were almost 25%, 1 in 4 students have cleared the NTSE exam. And these are our amazing toppers who have made us proud. So why am I telling you about NTSE? The reason is, doesn't matter which exam. It could be probably your younger brother or sister or some junior of yours who wants to learn about Vedantu, and do we have a footprint on 9th and 10th grade. So you should tell them, yes, Vedantu is for everyone, and you should also feel proud, and you should also feel confident. And this, establishes the fact that Vedantu's methodologies, the study patterns, the mock tests, the teachers are doing a wonderful job with the faith and the trust of the students and the parents in producing amazing results. And this is what we have been doing consistently, and even in JEE Mains and Advanced as well. 1,500 students cleared JEE Advanced last year alone from Vedantu. So quick revision concepts. And can we solve JEE if we listen to crash courses? Yes, definitely, Banapura. That's the whole idea about it. It is revision plus problem solving, Harishma. Okay, this session will be approximately 1.5 hours, plus or minus 15-20 minutes. Okay, education for bright future. Let's start. Are you guys ready? All right, Sandra, great. And yes, Fighters Gaming, please leave a comment after the video ends. I will respond to your comment as well. So in photoelectric effect, what are the important formulas that you need to know? Let's write it down starting from beginning. First of all, energy of a photon. The energy of a photon is hf, which is also hc by lambda, which you can also write it as 1240 upon lambda in Armstrongs, and this will be in electron volt. This is one such formula. Then the momentum of a photon is h by lambda. Okay, this is very important. This is for a photon. This is the momentum, and if you flip it across, then you get d Broglie wavelength. Lambda is equal to h by p. This is your d Broglie wavelength. D Broglie wavelength. And this momentum is the momentum of the particle. It is in fact root of 2 times kinetic energy times mass of the particle. So very, very important formulas. Okay, Jonas Joy, it is there in the major playlist, but I will create a separate chapter playlist also in the nurture series. Okay, don't worry, bacha. Shankar, this is a 12th standard chapter, so this will come later on. Kavisaran, it's dinner time, so yes, definitely I had my lunch, bacha. Okay, so next important thing, when a photon falls on a metallic surface, some of the energy is used to take out the electron from the metal. So that energy is called as the work function, and the remaining energy is going to go in the electron. So the energy of the photon goes in plucking out the electron. That is the minimum energy, which is called as the work function, and the remaining is the energy of the electron. So this is your work function, and this energy is in the form of kinetic energy. So what's the formula for work function? Some of you might remember it. What's the formula for the work function? Phi is nothing but hf naught. Hf naught, the minimum frequency for which the electron ejects, the minimum energy of the photon which is able to pluck out that electron. That is your critical frequency, the minimum cutoff frequency for which the photoelectric effect occurs. Ravi Ragul, like I said, bonus, one stone, one bullet, like Rajnikant. Rajnikant can kill 2 villains in one bullet. Same way, this chapter can take care of physics and chemistry, when you study it as such. So this is your critical frequency. Photoelectric effect occurs. This effect occurs only when the frequency is more than the critical frequency. Everybody remembers this? Very good. Excellent. Okay. Next, what is the maximum kinetic energy of the electron measured in terms of? It is measured in terms of the stopping voltage. These electrons are ejected. In order to stop them, you apply a reverse voltage called as the stopping voltage. So this basically Ke max of those electrons is E into Vs. This Vs is your stopping potential. Keep this in mind. Stopping potential. Very, very important formulas. Alright, very important slide. So many things right up on your screen. Alright, next thing up. Atomic structures, important formulas. Apart from remembering the radius, the velocity and the energy, radius, velocity and energy, you don't have to remember these numbers. No, don't remember that. The only thing that you need to worry about, I'll just highlight it for you guys. What is the thing that you need to remember? It is proportional to n square by that z should have been there. I'm not sure why that z is not here, but it should have been there. I'll just put it up over here. Okay, n square by n square by z. Okay, this z should be there. N square by z. This is what you need to remember. You can see that n square by z. Similarly, you should remember that velocity is proportional to Z by N. Z by N. You don't have to remember the constants. Then energy is proportional to Z square by N square. This is what you need to remember. Is that okay, bacha log? Now, the constant of proportionality, don't try to remember h square epsilon naught, you will get confused. Only remember certain numbers. What are the numbers that you will remember? Look at this. One is for radius. For a Bohr's first orbit, the electron in the K shell, in the first orbit, will have a radius of 0.529 Armstrong. This is what you need to remember. Or 0.53 Armstrong. Anything else in second orbit or for helium or for lithium, you will have a different radius. Is that clear? Very good. I'm so glad, Tanya, you are happy, and be happy like this only. Velocity, you need to remember the number 2.2 into 10 to the power 6 meters per second. That's for the first shell, first orbit, okay, for hydrogen. If it is some other atom or some other orbit, you multiply it by Z by N. Similarly, for energy, the number that you need to remember is 13.6. But yes, remember there is always a negative sign right over here. Okay, where did we go? Yes. So there is always a negative sign. Keep this in mind. Okay. So this negative sign is very important. Energies are always negative. Okay. Apart from this fact, certain more formulas are also there, like in Bohr's postulate. The angular momentum of an electron in any shell is always integral multiples of h by 2 pi, where n is your principal quantum number. That's very important. Also, this formula, magnetic moment upon angular momentum. Who can tell me what it is? Who can tell me? So Anna, it's almost the same, 2.2, 2.18, it's almost the same. Hi Vanakkam, Kaushal. Hi Arjuna, welcome. Yes, so who can tell me what is the magnetic moment? This is not mass, this is magnetic moment by L. It is an electron charge by 2 times of mass. Very important result. Banapura, it is negative because positive and negative charge will have negative energy. Just like in gravitation, do you remember the chapter of gravity? Remember the potential energy was negative? Same way, in electrostatics also, when two attractive charges are there, the energies are negative with respect to infinity. So, if you recollect the energy level diagram, it will be clear that the first shell or the K shell, alright, this is n is equal to 1, and then you will have n is equal to 2, then n is equal to 3, 4, and so on and so forth. Eventually, you will have the last shell, which is n is infinity, that will be at 0 electron volt. The first shell will start with minus electron volt, minus 13.6, and slowly the energy increases. At infinity, the separation, the standard potential energy is assumed to be 0. So with respect to infinity, it is negative. Is that clear? Okay. Yep. Ray optics is creative. It's based on logical thinking, visualization. So students who find it hard to visualize and creative thinking and logical thinking, they find it difficult. Otherwise, it's a very interesting chapter. So you should also know what the series are. The series of hydrogen. Lyman is when the electron goes from any shell to the first shell. Then you have Balmer when the electron goes from any other shell which is on the top to the n is equal to 2 shell. Then the Paschen series when it goes from any other shell to n is equal to 3. So Lyman, Balmer, Paschen, these are the important series of hydrogen which you need to consider and remember. And there is a formula for that given by the Rydberg's constant. 1 by lambda. Don't have to remember this, mug up this formula. Remember that this constant is Rydberg's constant. This whole number over here is the Rydberg constant. Keep this in mind. Okay. So this is what you need to remember. The value is roughly 1 into 10 to the power 7. 1.1 into 10 to the power 7. Okay. Ramu, I'm very good. This is for JEE 2022. So how to become good at rotation? Simple steps. Step 1. Watch my rotation lectures of nurture series. Watch it. Number 2. After watching it, after every lecture, start solving those questions which I did in class, side by side or even after the class, including the homework. Step 3. Open HC Verma, start solving the basic questions. Step 4. Use our revision material like Tattva and revision classes and all the other content which is available. That's it. You will master rotation like anything. And if you want to become even pro level, then watch my advanced level classes of problem solving, HC Verma and Irodo problem, which is again there as micro courses in the pro subscription. Trust me, that's it. You will become Veera level. You'll become like God level. Okay. Modern physics in class 11th book? No, Benedict, it is not. It is not. Okay. So Aryan, if you have backlog, you have lot of time, bacha. First focus on JEE Mains. When you cover JEE Mains, then you can slowly cover up for JEE Advanced. Okay. So if you are already prepared for JEE Mains, then all you need to do is solve higher level problems and use better books like Irodo and all of that. That's it. That's what you need to do. Okay, so remember this formula, very important for electrons transiting from any one shell to another shell. So this is the formula for the wavelength of the wavelength of the photon which is emitted because of the transition. Next, X-rays. Yep. Oh, it says JEE 2023, is it? Oh, my bad, Benedict. This is supposed to be for 2022. Okay, I'll just get it corrected later on. Okay, so don't worry. My bad. This is not supposed to be nurture. Oops. Mistake. Sorry, bacha log. Sorry. This is very bad. Nurture 2023 oscillations. So sorry. This is not the chapter. This is not for 2023. This is supposed to be for 2022. So sorry, guys. So sorry. Okay. Ignore that. Okay. Next. Okay. The X-rays concept. Remember, whenever you have a Coolidge tube, so in that Coolidge tube, you basically you have a filament and you accelerate the electrons. And they hit the target. The target is there over here, and once they hit the targets, you get those X-rays. Those X-rays intensity versus wavelength graph looks something like this, correct, like a dinosaur, and this is your lambda minimum. This part, the smooth part, is called continuous spectrum, and the continuous spectrum's minimum wavelength depends on the voltage by which it has been accelerated. The voltage, this voltage of acceleration. So it depends between what is the voltage with which you have accelerated the electron from the filament to the target before it hits it. Okay, is that clear? Very good, very good. Similarly, then the next concept is of characteristic. Characteristics depends on the target material. These peaks are characteristic. Remember, they only are decided by the target material's atomic number, and this is the formula which was given by whom? Moseley. This was given by Moseley. Moseley said the characteristic depends on the atomic number, not mass number, and that's how you made the periodic table. A and Z are constants. You don't have to remember the value of A and B. Usually it is given to you. Usually for K alpha, this B is basically 1. Okay, so that's something which you can keep in mind. Okay, very important things which you need to remember. Great. Let's move ahead. Okay. Oh my God, Abhishek, you want to watch it at 2x? If I speak fast, then I don't know, it will be like crazy, right? If you watch it at 2x. Okay, last concepts of nuclear physics. The radius of a nucleus is R0 a raised to 1 by 3. What is A? The atomic mass number. Keep this in mind. Correct? This A, I hope you recollect this. This was your atomic number plus number of neutrons. R0 is the radius of the element which has atomic mass number 1, that means hydrogen. That's 1.2 femtometers. This is femto. 10 to the power minus 15 is called as femtometers. Is that okay? Great. Next, here we have the mass defect. Mass defect occurs when two nuclei fuse, or basically two protons, neutrons, whatever, they combine together to form a nucleus. The masses before and after are different. That difference is called as the mass defect, and that mass difference goes as energy given by the famous Einstein's equation. The energy which is released or which is absorbed is the destroyed or created mass into speed of light square. Delta m is nothing but the difference of the masses of individual particles and the nucleus separately. So remember, the individual particles have different mass and the particles when inside the nucleus have different mass, because some energy is always lost or created or destroyed in this process of nucleus creation. And this is a very important number, 931 mega electron volt. If this mass is expressed in atomic mass unit, which is the usual unit of expressing mass for nucleus. Okay, last few things. Radioactivity, the rate at which Aryan, if you have not made notes for any subject and if you are in 11th, you better start going. If you are in 12th, then use the Vedantu's revision material, Tattva material and all those things, and all the notes which are given to you in the crash course. Or if you are already in Vedantu, you would be having access to all the previous lectures and their notes. Make use of that. That will be faster. Okay. So Games Master, I would see, I have taught in offline, I have also taught in online. I know the pros and cons of both the things, but it's not because I am right now in online, I am promoting online, but I truly believe that if I was a student and if I were to choose and if I were to tell my past, and if let's say online and offline both options were available to me at my time when I studied, I would have definitely gone with online. Number one, obviously travel time saving. Number two, I always used to find it difficult to understand concepts in the first go. So I never had the chance of re-watching or asking my teacher, please say it again. Now in online, I have that access. Imagine. Number three, I used to always find it difficult to make notes. Teacher will be so fast, I don't have access to writing notes fast or his notes as well. So here in online, all the notes, whatever we write, not just on YouTube, but also on our platform, are available as PDF. Number three, the tests are in online mode. That means I can give as per my convenience. I get detailed reports of timing, etc. Assignments are given. I can keep a track of my performance. I can keep a track of my test reports. Everything is there at one place. Plus, the best teachers are there at one place. I don't have to juggle between different institutes. Oh, here physics teacher is good. Oh, here that teacher is good. And not just that, additional micro courses. Everything falls in one place. That's why I feel online is better. Yep, I hope this is clear. Yeah. And Abhishek, that's definitely not true. I mean, cheating is possible. You might get very good marks even in online test. If cheating happens even in offline mode, what are you saying? People cheat in offline, coaching centers. But it really doesn't matter whether you cheat in online or offline, because at the end of the day, you will be writing the same exam and there you can't cheat. So it's all about competing with yourself. So that's what it is all about. And online, people say that, okay, Abhishek says that it affects the eyes. Definitely not true. I'll tell you why. Because, you anyways will be using mobile phones and computers and so many other things, number one. Number two, if you follow simple tips and tricks, okay, your eyes do not feel the strain, like looking away after every 10-20 minutes and just gently massaging your eyes and using you don't even have to use any filters or anything, just closing your eyes for some time and then opening the eyes in regular intervals. Think about it, even after a few years you will be joining a job which will have a computer in front of you. That is also online, right? Ask your parents, most of them will be sitting in front of your computer. So when they sit in front of computer, will they say, no, I don't want to sit in front of computer, sorry boss, I want to hold an axe and I want to cut trees. Yeah, that's offline. I want to cut trees. I don't want computer in front of me. Okay, fine, go ahead, go cut trees. Who is stopping you, right? That's how it is. Yep. Yes. Abhishek, I'm not sure who is on the bed. Those are the non-serious students. And the serious students, I'm pretty sure they are not on the bed, they are on a table. I'm pretty sure about that. I'm guessing you are on the bed right now. Don't generalize it for others. That's the wrong thing. Those are the notions that are fed into your head by different people. In offline, students are present, but they are dreaming about something else. They are dreaming about bed. They are dreaming about something. They are dreaming about some games. So it doesn't matter whether you are on a bed or whether you are physically present in the classroom. Where are you mentally? That's what matters. Correct? I hope I have cleared all your doubts. Yep, very true. So moving ahead, radioactivity, the rate of decay, which is also called as the activity of that material, is directly proportional to the number of nuclei present, and it is basically minus lambda times n, where what is lambda? Lambda is your decay constant. Decay constant. Very, very important. I hope this is clear. Very good. I'm so glad, Saifu, you agree with me. Okay. N is the number of material, number of nuclei radioactive which are present. And the activity is just dN by dt, like I just told you. You can also use the exponent formula for calculating the activity or the nuclei at any time in this particular format. So when you integrate this, you get basically N is equal to initial nuclei e to the power minus lambda t. Very important formulas. Half-life, the amount of time which it takes to make the radioactive sample to half its original value is called as the half-life. It is log of 2 upon lambda. And average life is the average time for which a nuclei stays before decaying into its daughter nuclei. The average of those times is called as the average life, and it is just the reciprocal of the decay constant. Okay, I hope this is clear. Aryan, mean, average life, they are different parameters to just judge a radioactive sample. Half-life tells you how much time it takes, for the sample to become a half. Average tells you for how much on an average these nuclei stay alive. It's just like finding average speed. Why do you find average speed? Okay, you want to know what was your on an average, what was your mean velocity between 2 points. Same way you are finding the average time a nuclei stays alive before decaying into its daughter. Alright, so I'm guessing I have explained to you all the benefits of online coaching. So let's move to some question solving since you have quickly brushed up all the concepts. Games Master, in the coaching, like in Vedantu, you will be giving the mock tests, assignments, tests in your home, okay, at your luxury, at your comfort. But when the actual exam is conducted, let's say JEE Mains or JEE Advanced or KVPY, you'll have to go to a center. There will be a proctor, or there will be some invigilator who will be invigilating all the students. In that center, in that computer, you are going to give the test. That's how it is. Hi Vishal, I'm so glad you are in Rishti K batch. I'm hoping to see all of you in the Sankalp batch of VPro next year, this coming year rather. Okay, so this is not 2023. I'm so sorry, apologize for this misprint. This is not 2023 class. It's a 2022 class, guys. Oh my gosh, I'm so sorry. Okay, all right. So in a photoelectric effect, on increasing the voltage, what happens? On changing the frequency, what happens? Anna Reddy saying option 3. Is it, bacha? Let's figure it out. Quickly try to post all the answers in the comment section, bacha log. In the comment section, bacha log. Come on, think about it. Okay. Come on, figure this out. What happens in a photoelectric experiment? What depends on what? Hi Surya bacha. Welcome aboard. What depends on what? Come on, think about it. Okay, let's see the final correct answer. Some of you are probably correct, some of you are probably wrong. The correct answer is B, it is not a C. Nope, it is not C. Okay, I'll tell you how. See, when you change the voltage, and how does frequency affect all of this? Let's recollect a graph. I don't know whether you remember this graph. There was a graph of your current versus the voltage, and the graph looks something like this. This is your stopping potential. This is your stopping potential, and the graph goes like this, and it saturates. This is saturation. This is saturation. No matter how much you increase the voltage, the current does not increase beyond a point. So increasing the voltage, does it change the saturation current? No. For no matter how much you increase the voltage, the saturation current remains fixed. It is given. But if you increase the intensity of the light, then for a different intensity, let's say for example like this, then you will have a new saturation, but this is for higher intensity of light. When you have more number of photons which are falling on the metallic surface, more photons will emit more electrons. More electrons is more flow of charge, and that means more current. So the saturation current increases with the intensity. Keep this in mind. Is that clear? And the last thing, will it depend on the frequency? No. Frequency, if frequency increases, the maximum energy of the electrons will change. If maximum energy changes, the number of electrons does not change. It's just that the electrons are moving faster. That's it. It will not affect the current. That's all. So the number of electrons which are still crossing is the same. So it does not affect the saturation current. Keep this in mind. All right. Moving on to the next question coming up on your screen. All right. Is that clear? Is that clear? Very good. Very good. Okay. Why can't two photons of low frequency attach an electron? Can we say photocurrent increases? No. Remember, Aryan breeze one simple thing. Always one photon interacts with one electron. That's the rule. Okay. That's something which is observed in nature. No two photons can interact simultaneously with one electron. So that's the reason why you cannot have more number of photons interacting and suddenly removing an electron out. Remember, that's the reason why you have something called as the cutoff frequency. Only when the photon's energy is higher than the takeaway energy or the work function, only then it can suck out that electron from the atom. Else 5-6 photons can gang up together and then they can take out an electron from atom. That's not what is observed. I hope that is clear. Okay, let's move ahead. Now, a photosensitive metallic surface has a work function of this much. Photon's energy is 2 hv0. It falls on the surface. The electrons come out with maximum velocity of this much. When the photon's energy is changed to 5 times hv0, then the maximum speed of the photoelectrons will be. Okay, many of you are saying option D. Let's figure this out whether you guys are correct or wrong. Meanwhile, when I was teaching or talking, I guess you guys have solved the question. Let's figure this out. See, the photoelectric equation is energy of the photon is work function plus the kinetic energy. Let's start using it. First time, the work function, by the way, is h nu naught, and the energy of the photon is 2h nu naught, and the kinetic energy, I'll just put it as k. Next time, the photon's energy is 5h nu naught, and work function obviously is the same. It will have a new kinetic energy. Now you can just see from this that k, if you shift this guy over here, is nothing but h nu naught, and from here you can see 4h nu naught, okay, is nothing but k1, but h nu naught is just k. So therefore 4 times of k is k1, and k is nothing but half m v square, and k1 is half m v1 square. Half m goes, so 4v square is equal to v1 square. What it means is also v1, taking root on both sides, is 2 times of v. 2 times of original speed, which is 4 into 10 to the power 6, is nothing but 8 into 10 to the power 6 meters per second, which is option D, I suppose. Yep. Hello Ashwin Raj, welcome to the channel JEE Enthuse. Go ahead, smash the like and the subscribe button so that you become a member officially. All right, so let's get going to the next question. Yes, the answer is 8 into 10 to the power 6. The idea was to use photoelectric equation 2 times and just eliminate the variables h nu naught. That's it. And kinetic energy is half mv square. Just solve it by eliminating the variables. Next question. Okay. So should I take rest for JEE and focus on boards? Shonak, not exactly Shonak. I have also prepared for Maharashtra board. Even I was a Maharashtra board student. What I did was I used to practice JEE problems during boards also, but of the topics which are there in boards. So let's say my physics exam is there, whatever topics are there in term 2, in your case, okay, I will do those problems during the boards whenever I'm bored, or just halka fulka, maybe 5-10 problems, 20 problems. So stay in touch, don't take rest, else that momentum that you have built up will be lost, and you will find a lot of resistance to catch up once boards are over. So don't let that momentum die out. Okay, moving on to the next one. You have a hydrogen-like atom. It makes transition from 4th state to the 3rd state and 3rd state to the 2nd state. The resulting radiations are incident on a metallic plate. The stopping potential for the shorter wavelength is this much. The stopping potential for the longer wavelength is how much? Okay, let's try and do this question. I hope you guys will be able to solve this. Very good question. The electrons for a hydrogen-like atom go from 4th state excited to the 3rd state. Now when I say 4th excited state, that means N is actually 5. First excited state is from 1st to 2nd orbit. So 4th is 4 plus 1, which is 5. So 4th excited state means N is equal to 5. To the 3rd excited state, so the 3rd excited state means N is equal to 4. And from there, it goes to 2nd excited state. So 2nd excited state means N is equal to 3. All right. Now, if you recollect the energy levels, between 4 and 3, the energy gap is a lot, but for 5, it's closer. I hope you remember the energy level diagram. It is big, that the lines become closer and closer as you go up on the higher orbits. Great. Okay. Okay. Shivansh, I'm not sure which school or which institution you are from. Probably you need to mind your language, number one. Number two, you need to understand that these mistakes do happen, and I have told you that it's not a 2023 class, it's a 2022 class. Learn basic behavior before even studying for JEE. A lot of students don't have these courtesies, they don't have these manners. So learn all these things, because you can learn physics, chemistry, maths from books. You can learn physics, chemistry, maths from teachers, but manners, they should be learned and taught from home. So make sure, and I hope your parents are going to teach you all these manners in the long run, because these matter more than PCM knowledge, obviously. You know? Come on, let's move on ahead to the next one. Okay, so what do we have over here? This energy gap, energy from 4 to 3, is much higher than this energy gap over here, energy from 5 to 4. The question is all about what is the wavelength which is emitted. Okay, now this energy difference leads to a photon emission. Makes sense, right? So this will be nothing but hc by lambda. Great. So read the question carefully. When the transitions happen, a photon is emitted. That photon falls on a photoelectric plate, and the stopping potential for those photons is given over here. That is what it has to be understood. Is that clear? Is that clear? Now, it is mentioned the stopping potential for the shorter wavelength. Who will be shorter out of these two? hc by lambda. When wavelength is short, the energy is more. So for shorter wavelength, meaning for higher energy. So this is the shorter wavelength. So this is lambda minimum, and this is lambda maximum out of the two. This is short wavelength, this is higher wavelength. All right. Now think about this. Now think about this. These photons fall on a photoelectric plate. Work function will be there. Stopping potential will be there. So my point is, can I write that hc by lambda, minimum, let's say, will be work function plus the stopping potential? I think it is clearly mentioned. stopping potential is 3.95 electron volt. This is the photoelectric equation I can write for the emission from the 4th to the 3rd orbit. The photon falls on the electric plate, photoelectric plate, and it emits an electron. So that energy of the photon is work function plus the potential to stop it. Make sense? Very good. Excellent. Everybody got it till this point? Now similarly for this photon which has higher wavelength, the photon which is ejected of longer wavelength, a similar equation can be written down. hc by lambda max, hc by lambda max is equal to phi, same work function, but it will have a different stopping potential. In fact, that's what we need to find. That's what we need to find. I hope this is clear. Everybody fine till this point? Cool? Everybody? Okay. Now, here is what I will tell you. This number over here is energy of 5 minus energy of 4. This is energy of 5 minus energy of 4. And this is energy of 4 minus energy of 3. Now I got some idea. If this number is E5 minus E4, and if this number is nothing but E4 minus E3, how about subtracting these two equations? How about subtracting equation 1 and 2? Remember, 1 lambda minimum is related to this one and this is related to this one. When I subtract this with this, observe what happens. Observe what happens. I will get, what is this? E5 minus E4, this number, minus E4 minus E3 is equal to, so on the LHS I had this and this, so this minus this will be this on the RHS and this on the RHS. So think about this, it will be phi plus 3.95 minus phi plus V1. I hope that is okay. I hope this is okay. Clear what we just did? So this energy difference is hc by lambda, and hc by lambda will be energy of 5 minus energy of 4. Similarly, this will be energy of 4 minus energy of 3. So just visualize these two numbers over here. So this expression minus this expression, expression 1 minus 2 will be this number minus this number. LHS minus LHS minus LHS, RHS minus RHS. Great. Now what will you get? You will get E5 minus 2 times of E4 plus E3 will be 5 goes, and you will have 3.95 plus V1. Now these numbers can be easily found out. I'll tell you how. Because we know it is like a hydrogen atom, and the hydrogen atom has an electron volt in the lowest energy as minus 13.6. And this is a hydrogen like atom with Z is equal to 3. What is the generic formula for energy? Generic formula for energy is minus 13.6 into Z square by N square. So just substitute everything, your job is done. So everywhere what will happen is minus 13.6 Z square, meaning 3 square, by N is 5, so 5 square, minus 2 times, and minus becomes plus, of course, minus of 13.6 and this minus, into 13.6 into 3 square divided by, what is it, 4 square, and again that minus will come. So what is it, 13.6 into 3 square upon, you will have 3 square again is equal to 3.95 plus V1. You can take few things common, like 13.6 is common, 3 square is also common, that means 9, and you will be just left with minus 1 by 25 plus 1 by 16 and minus 1 by 9 is equal to 3.95 plus V1. So just solve this onwards you can solve it. Solving this, you will definitely get the value of V1. You'll just get the value of V1. Is that clear? Okay. You'll have to fill it in online mode and you'll get the notification on this channel. Don't worry. So the answer comes out after solving as 0.75 electron volt. So that's something which you can do. So solve this, you should get it close to 0.75 electron volt. Just take the LCM and just do the cuttings. Now, this question is obviously of advanced level. These are the kind of questions you can expect in advanced. You can also expect these kind of questions in SX. Okay, so keep this in mind. This is obviously not mains level. Reason, there are multiple concepts involved. Energy, transitions, then photoelectric effect and mathematical manipulations. Okay, so what have we done in this question is the electron, when it goes from excited state to lower energy state, photons which are emitted, those photons are responsible for the photoelectric effect. But there are two such transitions, one from here to here and one from here to here. Hence we had two photons and two photoelectric equations. We just had to get rid of phi by subtracting these two, and the rest was just pure maths. That's how you get the answer. I hope I have explained you the summary of the question. Can we move ahead, my warriors? And did you love this question? Yep. Let's go ahead. Here's your next question on your screen, and here is a question on hydrogen atom which has an electron of mass m and charge e, and it is making an orbit of n revolutions per second. If the mass of the nucleus is capital M, then the magnetic moment associated with the orbital motion of the electron is. Come on, my warriors. Let's see how many of you can do this. Okay. Yes, I will, Monisha, don't worry about it. I will definitely. Okay, we will be starting over here. Don't worry. Is KVP and JEE syllabus? Yeah, it is roughly the same. All right. Monisha, I'm planning some things in the days to come for JEE 2024 too. Okay, don't worry. Okay, let's start this. In hydrogen atom, an electron of this mass making some revolutions. So what do you think is the magnetic moment? I just gave you a formula for magnetic moment. So the formula for magnetic moment was, if you recollect, upon angular momentum was E by 2 times the mass of the moving particle. In this case, it is the charge. Electron's charge mass is m, so 2 times of m. Therefore, magnetic moment will be E by 2m into L. But what is L? Angular momentum. And that's simple. I'll tell you how. Angular momentum is I omega. Moment of inertia is mr square, and omega is nothing but 2 pi frequency. Frequency is n revolutions per second. So this is just n. Why is it mr square? Because it's a point mass, distance is r. So point mass at a distance r, the moment of inertia will be just mr square. Correct? Great. Very good. Sadiq, I'm not sure which device you are on, bacha. Only for JEE and advanced, Sai Ganesh. Okay, not for GATE. GATE is for post-grad and all of that. So just use that value over here. So m r square 2 pi n, and the remaining values are just from here. E by you have 2m over here. So you can see m and m goes, this 2 and this 2 goes. So you are just left with E r square pi n. And is such an option there somewhere? I think it should be option D, my warriors. Yes, it is. Yeah, can you see that? So two concepts involved. Number one, rotation motion, angular momentum. Second concept, the ratio of magnetic moment and the angular momentum is charged by twice the mass. That's it. Rest all are just there to confuse you. Okay, let's move to the next question coming up on your screen. Here we go. Good evening, headhunters. All right. So what do we have over here? There is 24.6 electron volt which is required to remove one of the electrons from a neutral helium atom. Okay, fair enough. And to remove the next and both electrons from the helium atom, how much energy will you require? Okay, I'll tell you the crux of this problem. Okay, great. So here it is. Observe. Now, in a helium atom, okay, this is a helium nucleus, you have 2 electrons. Remember that, you have 2 electrons. And the ionization energy won't be the same for both the electrons. How many of you agree with this? How many of you agree with this? Is that Clear? Why is it not the same? Because when the first electron is removed, the scenario is different. The second electron is still revolving. That changes the effective charge and the dynamics of the problem. Similarly, when you remove the first electron, the effect of the first electron is gone. So to remove the second electron, the amount of energy required is completely different. And keep this in mind, once you remove the first electron is taken out, what is remaining over here in this helium nucleus is just one electron, and when you have to take out that one electron, this helium nucleus with that electron behaves like a hydrogen-like atom. Remember, when you study Bohr's postulate, it is assumed that the effect of other electrons is not there. Those charges will not affect each other. Is that clear? Yes, this is a 12th standard topic. Ignore this over here. This is supposed to be 12th standard, bacha log. Okay. Now, if this much is understood, you'll also would have appreciated the fact that the energy required to remove this and remove this is completely different. Now, according to the given question, to remove the first electron is 24.6. Then you'll be like, okay sir, second electron also will take the same electron volt. No. Their energies are going to be different because the effect of other charges are going to be there when the first electron was removed. For the second electron, when it is removed, use the Bohr's formula. Because Bohr's formula, is used when no other charges are present around it. So the energy required for the second electron, you can just use the energy formula, which is nothing but 13.6 into Z square by N square. 13.6, Z is helium, so that means it is 2 square, N is 1. So this will be 13.6 into 4. So this should be 54.4. Just check this out, electron volt. So this is the amount of energy needed to remove the second electron. Now, what is the total energy needed? The total energy needed will be the energy needed to remove the first electron, which is 24.6, plus the energy needed to remove the second electron, which is 54.4. How much will it be? Just check this out. Yep. Come on guys. Is it not going to be 79? Just check this out. 79 electron volt. Is it there somewhere? Yes, it is there. That's the answer. So many students just multiply this number with the 2 and they get a wrong answer. Because they forget that when the first electron was removed, the scenario was completely different. This electron was affecting it. The effective charges were different. So when you remove the second electron, those effects are not there, and hence you can use the Bohr's formula. This formula is not applicable for the first electron which is removed. Is this question and the concept clear? Is this understood? This can be asked in many different ways. Okay? It's a brilliant question, guys. Many students will definitely make a mistake of multiplying by 2. Okay, here we come to the next question coming up on your screen. You have to focus on JEE preparation obviously, and then focus on board preparation. Follow the timetable which I have given you. It's there on the channel, 45 days strategy by Shreyas sir. Watch it. Okay, 45 days strategy. Okay, here is the next question concept. Let's see. Electron in a hydrogen atom first jumps from second excited state, then to the first excited state, and then from the first excited state to the ground state. The ratio of wavelength, momentum, energy be A, B, C. What are these ratios? It's a MCQ question. Multiple options could be correct. A, B, C, B, C, D, A, B, D, A, B, C, D. I don't know. Let's find that out. Hisham, this is of slightly higher order for JEE Mains plus Advanced, but yes, it is definitely useful for NEET as well. So, if you notice, second excited to the first excited, and then from first to the ground state. So this is, let's say, second excited, then this is, let's say, first excited, and this is, let's say, the ground state. Ground state is n is equal to 1, first excited is n is equal to 2, second excited state is n is equal to 3. Okay, next, if you jump from here to here, okay, if you jump from here to here, there will be some energy, and here to here will be some energy. Ratio of wavelength, etc. is asked. So this energy, let's say I call it as E1, let's say this energy is E2. We want to find the ratio of energy also. So let's start with energy. If I find energy, I can also find momentum, and I can also find wavelength. Is that agreed? Why? Because when the electron jumps from here to here, a photon of certain energy is emitted. When I know energy, I can find the momentum of that photon. I can also find the wavelength of the photon because of the formulas. Because of the formulas. What are the formulas that you will be using? Simple. One of the formulas that I'll be using is E is equal to, hc by lambda. That's one of the formulas. And another formula which I'll be using is lambda is equal to h by p. So if I know energy, I can find wavelength. If I know wavelength, I can find momentum. That's how I go about it. Is that making sense? So let's start with energy first. So what will be the energy for this to this? Simple. It will be nothing but, it will be some constant, that z square, 13.6, all those things. And here you will have 1 by, you'll have 2 square and 1 by 3 square. Correct? Is that making sense to you? Okay, so what will this be? A constant, and 2 square is 4, 3 square is 9, 1 by 4 minus 1 by 9, so it will be 9 minus 4 by 9 into 4. So that will be constant. 9 minus 4 is 5 divided by 36. That's what you get. Similarly for here, you will get some constant, and you will have 1 by, 1 and 2 is there. So 1 square minus 1 by 2 square. So this will be constant, into 2 square is 4, this is 1. So 4 minus 1 by 4, of course. So this will be constant into 3 by 4. Now let's start with this. What will be E1 by E2? This will be ratio of energy. Energy's ratio is C. So this will be basically your C. That ratio C. This will be this by this. This by this. So think about it. It will be that constant into 5 by 36 divided by constant into 3 by 4. Shift it and see what you get. So you'll have 5 and 36. You'll have 4 on the top, 3 below. This goes 9 times. So this will be 5 by 27. 5 by 27. So C value is 5 by 27, and I have it in option D. Yep, can you see that? It's there in option D. Very good. Next, we have to find the ratios B and A also. That's not difficult. I'll tell you why. If you look at lambda, lambda is inversely proportional to energy. That means that ratio B, which will be lambda 1 by lambda 2, will be exactly E2 by E1, which means it will be, look at this, where is it? Yep. So, that is, sorry guys, B is for momentum, my bad. Just hold on. Let me erase this. So sorry. Lambda is for, wavelength is for A. So the ratio of wavelength is called A. So hence, I can say that A, which is going to be lambda 1 by lambda 2, it will be E2 by E1. That means it will be exactly reverse of this. So it will be 27 by 5. So A is 27 by 5, so wrong. C is obviously wrong. Okay, last thing. Momentum is inversely proportional to lambda, and lambda is inversely proportional to E. That means it is directly proportional to E. So the ratio B, which is P1 by P2, will be just E1 by E2. So that means it will be just 5 by 27. Is 5 by 27 there? Yes, it is there. Yes, Achiever, DG Pandey, Tathwa and PYQs is more than enough for cracking the exam. I think C and D is correct. Yes, it is. A and B are wrong. Alright, is that clear, my warriors? Understood? Clear? Shall we move ahead to the next question? Look at this, such a beautiful question. It looked complicated. It's a JEE Advanced type of question, obviously, because multiple choices are, multiple options are correct. But the beauty is, once you solve one of them, automatically the other two get solved very easily. Thank you for reminding me. I often forget to stay hydrated. Thank you so much. Let's move on to the next question. Okay, I think Ajivar, I have just answered your question some time back. So if the shortest wavelength of the continuous spectrum coming out of the Coolidge tube is lambda, then the de Broglie wavelength of the electron reaching the target metal in the Coolidge tube is approximately. Let's solve this question. Okay, so the wavelength of the continuous spectrum coming out of the Coolidge tube is lambda. Okay, so remember, you always have a filament and it hits the electrons which are accelerated, they hit the target and you get X-rays over here. In the given question, the de Broglie wavelength of the electron is asked. So the electron is a matter. A matter has an associated matter wave whose wavelength is called as the de Broglie wavelength. Great, we have been asked that. Now, if you remember the formulas, it will be very straightforward. If you accelerate the electron by some potential difference, let's say delta V, okay, then you can say that the kinetic energy of the electrons is charge of the electrons into delta V, and this happens to be the energy of that X-ray photon. This happens to be the energy of the X-ray photon, the maximum energy that it can have. The max energy of the photons which can come out will be from the kinetic energy of the electrons. Maximum energy, that means the shortest wavelength. So the shortest wavelength is hc by lambda. In this case, the shortest wavelength is given to be lambda. I hope this is clear. Everybody clear about this? Perfecto? Moving ahead. Next, this kinetic energy of that electron can be written in terms of, this kinetic energy can be written in terms of momentum. It's p square by 2m. It's momentum square by 2m for that electron. Now, de Broglie says momentum and wavelength are related, and that is 1 by 2m. Momentum is h by lambda of de Broglie. This is your de Broglie wavelength. This is square. This will be obviously hc divided by lambda. It's just a matter of rearranging these things. You can see one of the h will get cancelled out. Can you see that? So h by 2m into lambda d is equal to c divided by lambda. We had to find the de Broglie wavelength, so shift it over there. Oh, sorry, this is lambda d square. Yep, shift it over there. So lambda d square will be h into lambda. C comes down, so 2mc. That means lambda de Broglie will be root of everything over here. So h lambda divided by 2mc. I think that should be your final answer. What a brilliant question. Brilliant question it is. Loved this question, guys, because de Broglie is there, X-ray concept is there, energy of photon is there, kinetic energy to momentum transformation is there, that work kinetic energies formulas, and momentum related to the wavelength. It's a lovely question, and how you can relate both these concepts. Moving on to the next one. Let's see how many of you can do this. It's a very simple conceptual question. If the potential difference between the anode and the cathode of an X-ray is increased, what happens? Will the peaks move? Will the peaks remain the same? Will the cutoff wavelength decrease? B and C both are correct. Okay, let's see. Come on, my warriors. Post all your answers in the comment section now. What do you think should be the answer? This is your wavelength versus intensity graph of X-rays. This is your cutoff. These are your characteristic. Remember this dinosaur? Okay, the intensity versus wavelength graph of X-rays which come out of a Coolidge tube always look something like this. Which of these wavelengths get affected? Think carefully and answer. Come on, my warriors, figure this out. Come on, think carefully. Okay, come on, figure this out. The potential difference. What will happen if it is increased? Think carefully. If the potential difference increases, remember E into delta V is HC by lambda minimum. This is the formula. If potential difference increases, lambda minimum decreases. So this one will decrease, so it will go here, left side. And these peaks, they are characteristic. They are characteristic and they only depend on one thing, the Z of the target and nothing else. The target is the same, only voltage has changed. Look at it now and think, if the potential difference has changed, what will happen? Will the peaks move? Obviously not. Peaks will remain at the same wavelength. Cutoff wavelength at P, yes, this will decrease. So both B and C are correct. That's the correct answer. Got it? So brilliant question. And you should know that characteristic depends on the target, and this cutoff wavelength of the continuous wavelength spectrum depends only on the voltage difference. That's it. Option D is correct. Very good. Let's move to the next question coming up on your screen. To find the relationship between K alpha and L beta of X-ray spectrum, assuming it like a hydrogen-like atom. Okay, what it means? Okay, let's draw the shells K, L, M, and so on and so forth. This is your K shell, this is your L shell, this is your M shell, and this is your N shell. Okay, K, L, M, N. Okay, now when I say K alpha line, K alpha means the first transition that can happen above the K shell. So when an electron from the L shell comes down to the K shell, that wavelength which is emitted is called as the K alpha wavelength. L beta. Now what is L beta? To understand that, remember what is L alpha. L alpha is when the electron transits from here to here. Here to here. The first transition that can happen, that is L alpha. So this transition is called as L beta. As simple as that. Now K is where, it is 1, L is 2, this is the third shell, and this is the fourth shell. You should remember this. Obviously, it's very easy to understand and also remember. Now, let's find the relationship between them using Bohr's model of atom. Remember your Rydberg's constant formula? Rydberg's constant formula. So just use that. 1 by lambda. Ankit, go back to the past. The starting part of the session. In this session only, I have given you all the series and what are the transitions. Just go. It's there in the PDF, also in the lecture. It's somewhere there on the side. Just go at the start of the class. Okay, Ankit? So 1 by lambda will be R Z square, and the transitions N1 square, N2 square should be there over here. So for the K alpha line, the transitions are from 1 and 2. So here you will have 1 by 1 square and here you will have 1 by 2 square. I need to use this formula because you have to find the relationship between K alpha and L beta lines, the wavelengths. You have to find the relationship, the mathematical relationship between them. Okay, so what do I get? R Z square, and 1 minus 1 by 4, that is nothing but 3 by 4. So that is 1 by lambda of K alpha. Similarly, you can find the lambda of L beta. So 1 upon the wavelength of L beta will be R, same Z. Here you will have 1 by, look at it, 2 and 4. Those are the shells. So 1 by 2 square minus 1 by 4 square. So this will be R Z square. This will be 1 by 4 minus 1 by 16. LCM is obviously 16. So here you will have 3 minus 1. I hope. Yep. Oh, sorry. What am I doing? So sorry, guys. So sorry. Yeah. LCM is 16. And here you will have 4 minus 1. Yep. And this will become R Z square into 3 by 16. Now that I have these two things, all I need to do is find their ratio. My job is done. Observe now. Just observe. I'll just take the ratio of these two things. This divided by this. So 1 by lambda of k alpha upon 1 by lambda of L beta will be RZ square is the same, right? Here as well as here is the same. So don't even bother writing it. On the top you have 3 by 4. At the bottom you have 3 by 16. So this becomes lambda of L beta upon lambda of k alpha will be 16 goes on the top, 4 comes below. So this will become 4 times. This will become 4 times. But I wanted to find the reverse. So lambda of k alpha upon lambda of L beta, that will be 1:4. That will be 1:4. I hope this is clear. Yep. Pranish, I've already made a video on this. I have made many videos, so watch those videos. It's there on the channel as well. Okay, 1:4. Great. Why can't we use Bohr's model for all the other elements with multiple electrons by taking effective nuclear charge and screening effect? Okay, very valid point, Aryan. There are multiple problems. Number one, Bohr assumed that the electrons go in circular orbits, but electrons don't necessarily go in circular orbits. Number one. Number two, electrons are not in just orbit, but they also have suborbitals. So that also makes a difference. Number three, when you have multiple electrons, the mass of the electrons also needs to be slowly accounted for, and what matters is the reduced mass of the system. Number four, the effective charge concept is only applicable when you consider a model where the electron cloud is uniformly distributed and the other electron is going in a circular orbit. But if the cloud is not symmetrically distributed, there are orbitals like p, d, etc., then you cannot just take the screening effect or the effective charge, because the charge will get affected differently at different locations in 3-dimensional space. So that creates a problem. I hope that is clear. Okay. So Chikala, Dipya, for entering into NITs, you should have good NITs, decent branch at least, or decent NITs, decent branch, at least 98 percentile. Okay. Chalo. Let's move on to the next question. 1:4. Which of the following is a correct statement? Which of the following is the correct statement? Come on, think. Beta rays are same as cathode rays. Gamma rays are high energy neutrons. Alpha particles are singly ionized helium atoms. Protons and neutrons have exactly the same mass. Okay, Miss Abhyam is saying B. Hi Ajit Kumar. Okay, come on, figure this out. Modern physics, if you know it, it's easy. If you don't know it, and if you just see the questions, it will appear tough. You will be like, what the hell is happening? Rocket science. I'm not able to get head and tail of it. Other chapters like mechanics, at least you know, okay, this block moves, this pulley falls, okay, you can understand. But modern physics, you either know it or you don't know it. That's okay. Many of you are wrong. Some of you are only correct. Option A is correct. Guys, gamma rays are high energy neutrons? No. Gamma rays are high energy photons. Keep this in mind. They are photons. It's a gamma ray, X-ray, microwaves, electromagnetic spectrum. Those are photons. They are not neutrons. Alpha particles are singly, no, they are double ionized. Okay, so they are doubly ionized. 2. Okay. Protons and neutrons have exactly, no, approximately. In fact, the mass of a neutron is slightly more than the mass of a proton. Slightly, very slightly. But it is not exactly same. Beta rays, that is electrons, is nothing but your cathode rays. That's it. So that's option A, which is correct. Okay. Oops, where did we go? Yep, that's correct. Is that clear? Okay. Why did you use your profession, sir? I did not understand. CS Praveen, what is your question? Happens. Mistakes happen. Here is the next question. Okay. Binding energy per nucleon versus mass number are given for W, X, Y and Z are the 4 nuclei which are indicated on the curve. The process that will release energy is, which process will release energy is the question. Let's see how many of you can do this. Tushar, I won't suggest you to watch one shots because your NEET is in July. You should watch proper lectures because you have time. Don't do that mistake. If you watch one shots, it will not do you any good because you will lose out on so many minute things, and that will not give you 120 plus marks, 100 plus marks. You can get up to 120, maybe using one shots. That too with great difficulty. I mean, you need to prepare properly. You should have basics clear. Otherwise, if your basics are not clear, just don't watch one shots. You should have some idea, some decent level of preparation, then watch one shots. That will do wonders. Okay. What happened? Supreme Court decision, I think Supreme Court just said, right, they will not cancel the board exams. They will not even remove the subjective pattern. The subjective pattern will be there for the board exam. Yes, Aryan, I will be doing JEE Advanced exclusive problem sessions as well. These problems are mains plus advanced, both kind of questions I am doing. You can see some are multiple choice, some are integer, some are subjective, some are single choice, all those things, and there will be exclusive JEE Advanced questions as well. Okay, many of you are saying B. Nope, answer C is correct. Answer C is correct, and some of you got it correct. Very good. I'll tell you why. Release energy. See, this is most stable. This is in fact the stability chart. If more energy is released per nucleon, it is more stable. If you remember the binding energy per nucleon versus mass number chart, it gives you the idea of stability. This is very less stable, more stable, and again less stable. Now if you notice, Y to 2Z, Y to 2Z, come on, this is very stable, this is very stable, this is unstable, this is unstable, slightly, relatively. So obviously, if you are going from stable to unstable, why will it release energy? It will absorb energy. In fact, this will be absorbing energy. If you look at these, what you need to do, not many people realize, it's not so easy. You guys are thinking, oh sir, we can look at it stable to unstable, unstable to stable, I'll get it. The problem is, look at the option B. W going to X and Z. W going to X and Z. If you look, X is slightly more stable, Z is unstable, so now it is confusing. As compared to W, X is stable, Z is unstable. Now will it become more stable or less stable? I don't know. So you need to use math. How? Observe. For W, what is the total binding energy you find out? What is the energy needed to bind it? Binding energy per nucleon is 7.5 and number of nucleons is 120. So it will be 7.5 into 120 is the binding energy. Is that clear? What we are trying to do over here? We're trying to find the total binding energy of that W nucleus. 120, 75. 75 times 750 and 75 into 2 is 150. 150 plus 750, that's 900. So this should be 900 electron volt. Okay, 900. I hope this is in electron volt. Okay, or even if the units are not mentioned, it's okay. I'm just bothered about the numbers comparison. Now look at X plus Z. Look at X plus Z. This X is going to have an energy of 90 into 8. Check this out. 90 into 8. So this will be 720. Okay. Next thing. Look at Z. Z will have an energy of 30 into 5. Binding energy per nucleon, there are 30 nucleons. So that's why 30 into 5. Yeah, 3 5s are 15. So 150. Okay, I hope this is clear. Yep. Yes. Fair enough. Now look at the addition of these two numbers, 720 and 150. Just look at this. Just look at this. Okay, I hope everything is fine. 35. Okay. Yeah. Now just look at the addition of these two numbers, 720 and 150. 72 plus 15, that's 87. So I hope you can see that this sum over here which is nothing but 870. Can you see that, guys? Can you see that over here? That energy is basically less than 900. What does it mean? It means whenever energy is more, it is more stable. Whenever energy is less, it is less stable. So from more stable, it is becoming less stable. That means energy will not be released, it will be absorbed. Absorbed. In fact, how much energy will be absorbed? You will see 30 units of energy will be absorbed from this to this process. Got it? That's what you should infer from this. See, more binding energy means more energy is released. This is more stable. In this, if you add these two, 870, energy is released, but it is less as compared to before. Less energy released, less stable. If it is less stable, it will not release energy, it will absorb energy. I hope this is clear. Now, try to do this for this particular reaction. W you already know from here. W is nothing but 900. Y, what is Y? Did I find it out for Y? No, I did not find it out for Y. Let me use some different color. So for Y, what was it? Where is Y? Y is 60, and this is 8.5. So this is 60 and into 8.5. But there are two such Y atoms, so that's why I need to multiply it by 2. 8 2s are 16, so 6.5, which will make it 17. So 60 into 17, 17 6 are 102, so 102 matlab 0. So now check this out. 1020 is definitely more than 900. Oh, this is more stable. This is more stable. If this is more stable, it will release energy. Hence, this process will release energy. Understood? Got it? That's a brilliant question. If you try for the D option, you will see that it will be just probably like the B option, where the final energy is less, initial energy is more. So it will make it from stable to unstable. So that's why even D option is going to be wrong. You can just sit and calculate it. Is that clear? Isn't that a brilliant question? This is advanced type of question, my warriors. This is not mains level. Also, this can be considered as SX level question. Good evening, T. Pavan Kumar. What is my expected level of difficulty for NEET? Tushar, I think it should be in between 2021 and previous year paper, or it could be even similar to that. I mean, it can't be more difficult than the previous one for sure, because they will consider the pandemic effect and the school closures and all those things as well. Don't worry. Okay, moving on to the next question. If everybody is here and if you all love this question, do not forget to smash the like button down there. Okay. A radioactive nucleus decays according to the following series: alpha, beta, alpha, gamma. Starting from the first element, which has atomic number 72, atomic mass number or atomic weight 180. What's the atomic number and atomic mass of the last element? Come on, this is fun. You should be able to give the answer before I write it down neatly. Come on, do this question, guys. It's very easy. The first element had atomic mass number 180 and atomic number 72. So when it emits alpha particle, what happens? 4 is the amount by which the atomic mass number decreases. So this will become 176. Atomic number reduces by 2. So it will become 7. It will become 70. Okay. Next, what is emitted? Beta particle. When beta is emitted, atomic weight number does not change. It will remain 176. 70 will become 71. Atomic number increases by 1. Again, alpha particle is emitted. So 176 will become 172. 71 will become 69. 71 minus 2. Correct? And lastly, gamma. Gamma will have no change. So it will be 172 and 69. Do I have such answer? Do I have such answer? Yes, I have it. Do you see? Option C is there. Diffraction is only fine for mains perspective. I won't give it too much importance. If you might get one question. Sometimes there were cases when there were no questions at all. Oh, is it train man? I will definitely check after the session is over, bacha. Okay, Shankar, yes, it is option C. Okay, next question. The half-life of radioactive substance for alpha decay is 40, for beta decay 20. The fraction of the sample that will decay in a time of 80 years if the substance is decaying both in alpha and beta simultaneously. Okay, let's see this. Yeah, the previous one was JEE Mains type. Whenever a radioactive material decays via two ways, let's say this is producing alpha, this is producing beta, and this one has lambda 1, this has lambda 2, then the equivalent constant is given by this formula. Keep this in mind. Lambda effective is just lambda 1 plus lambda 2 for parallel reaction, for parallel radioactive reaction. Very, very important. The decay constants, it is decaying like this also and decaying like this also. The decay's constant will get added up. So you can very well say 1 by T effective, because this is log of 2, this will be log of 2 by T1 plus log of 2 by T2. Log gets cancelled, so 1 by T effective will be 1 by T1 plus 1 by T2. This was asked in JEE Mains. And now here the question is slightly more advanced. The decay constant of first one is, half-life of the first one is 40, of the second one is 20. Okay, fair enough. So 1 by 40 plus 1 by 20, LCM is 40 of course, and this will be 3. So T effective will be 40 by 3 years. Okay, this is the first step of the problem. Is there any chance to crack your dream, Pavan? Yes, there is. Please start watching the Nurture series right from the beginning. You have time, bacha. First complete your major topics. Watch my search on YouTube. How to cover 11th standard backlogs. Shreyas sir. Backlogs 11th Shreyas sir. Just search for it. You will get the video. Watch that video. All your doubts will be answered. Okay, bacha. Now comes the tricky part. Observe. How much time are you waiting? 80 years. 80 years is the time. Is 80 a multiple of 40 by 3? What multiple is 80 for 40 by 3? So 40 by 3 into how much? 40 by 3 into how much? This is needed for solving the question. It makes it very easy. 40 by 3, come on. 6, right? 42 is 80. So this 6, you know what is this 6? It's the number of half-lives. There are 6 half-lives. 6 half-lives. Aryan, follow my advice. Trust me, you will get JEE Advanced 1K rank. Follow my lectures, follow the books which I have told you there. I mean, I have produced 2-digit all India rank, so I know what it takes. Just follow my advice. You will get it. And I'll be there clapping for you when you get below all India rank 1000. 6 half-lives. Now when I say 6 half-lives, for every half-life, the number of nuclei becomes half, and then half of that, and then half of that. So, how many, or what is the fraction of the sample that will decay? So if I ask you, what is the sample which has decayed, the sample which has decayed, but the question is, okay, what amount of sample, how much sample is decayed? First we need to start with how much sample is remaining, and then we'll get the sample decay. So the sample remaining, how much sample will be remaining will be, original sample is, let's say, N0. The final sample remaining will be half, but raised to 6 times. Every time it becomes half of the previous one. So final sample which is remaining will be the initial sample into whatever that half raised to the number of half-lives. Makes sense? Makes sense, bacha? Very good. Now think how much sample, if this is remaining, how much sample has decayed? The amount of sample which has decayed will be original sample minus the sample which is remaining, that means N0 by 2 raised to 6. this is nothing but, you know, n naught, and this will be 1 minus 1 by 2 raised to 6, 2 raised to 3 is 8, then 16, then 32 and 64. So this will be 64. So this will be n naught into 63 by 64. So the sample decayed is the original sample into 63 by 64. So 63 by 64th sample has decayed in 80 years. Is that a number there somewhere? Yes, it is there. Yep, option A is correct. So the catch was not to find the sample which is remaining, but to find the sample which has decayed. This formula always gives you the sample which is remaining. Half into half into half is the sample remaining. So the amount which is decayed is original minus what is decayed. So that's how you get the number. So brilliant. Okay, great Pawan. So glad. All right. Aryan, my support is and my blessings and my lectures are always there with all of you. See it, you know, you are very fortunate that you have YouTube, you have online resources, you have the question banks, mock tests. Trust me guys, we didn't have it during our times. You are very lucky generation. You have the best technology. You can use it for distractions. You can use it for getting into your dream college. It's completely in your hands. No matter which teacher, which institute you join, cannot change what you are going to do. We are there at Vedantu to, you know, to motivate you, to give you the right resources, to help you show the path. And I will tell, listen, I'll turn on the torch and I'll be like, hey, follow this path. But it's up to you to actually go in that path. You cannot say, oh, no, sir, I want to explore the dark. Be my guest. I don't know, there could be a pit down there, there could be a cliff down there, it could be a mountain. I know what path has to be taken. So just follow everything. Trust me, you will be in IITs and you will remember all of these things eventually one day. Alright, so here is the question. Two radioactive substances X and Y initially contain equal number of nuclei. X has half-life of 1, Y has half-life of 2. After 2 hours, the ratio of activity of X to the activity of Y will be how much? Okay. Ratio of the activities is asked after some time, which means we need to use this formula. Activity is original activity into e to the power minus lambda t, and activity initially is lambda into original number. Okay. Now, according to this question, after 2 hours, the ratio of the activity of X to the activity of Y. Okay. What we will do, you know, instead of finding the activity ratio, because think about it. Okay, I'll just show it to you over here. Activity is nothing but lambda into n. I can also find, you know, the ratio of n, and then I can solve it. It's up to you. I mean, there are multiple ways of doing it. Okay, so let's do one thing. We have to find the ratio of the activity. Let's go over here. So A1 by A2 will be equal to, look at this, lambda into N1, but this is lambda of 1 upon lambda 2 into N2. Now, what is lambda 1, lambda 2? These are the decay constants for X and Y separately. N1 and N2 are the amount of X and Y present after 2 hours. Keep this in mind. Okay. Now, next, I will write it like this. This is lambda X, this is lambda Y, and N1 and N2 I can write it as N naught e to the power minus lambda X into T. N naught is the initial amount upon N naught into e to the power minus lambda Y into T. Is that clear? Everybody fine till this point? Everybody fine till this point? Great. Okay. Now, is this question for JEE 2023? No, bacha. Oh my god, I'm tired of answering this. This is a JEE 2022 class. This is a misprint. Ignore that if it is there in the title also. Now, what do we do next? Okay. See, lambda X and lambda Y are not given, but the half-lives are given. Okay. We can make use of that somehow. So, let's write this down. Lambda X by lambda Y will be exactly inverse of the half-lives. Because recollect, the formula for lambda is log of 2 by t half. So lambda 1 by lambda 2 will be t2 by t1. So I might as well write lambda x by lambda y as t half of y upon t half of x. And here n naught goes. So this will become e raised to, take this number on the top. So e raised to lambda y t minus lambda xt. Just I'm adding, subtracting the powers. Okay. Now this number y by x, half-life of x is 1, half-life of y is 2. So this will be 2 by 1, I suppose. Is that right? Is this 2 by 1? Okay. Next, this will be e raised to lambda y minus lambda x. Okay, what do I do for this? Okay, I know what to do. Lambda is log 2 by half-life. So I can write it as log of 2 divided by half-life of y. Half-life of y is 2. So this will be 2 minus log 2 divided by half-life of x, which is 1. Oops, not log, my bad. So I can just put it as 1, and t is common from both. The time is 2 hours. So I'll just put 2 over here. Okay. Now a lot of mathematics will be involved over here, especially the logarithms part. Observe carefully now. So therefore, a1 by a2 will be 2:1 into e to the power. This is log 2 by 2 minus log 2. This will be minus log 2 by 2. So this will be e raised to minus log 2 by 2. I hope this is clear. Into 2. So this will become 2 into e to the power. 2 gets cancelled. I will have minus log 2. Minus log 2 is nothing but e to the power log of 1 by 2. And e raised to log x is just x. That's the formula. So this will be 2 into just half. Remember what formula I have used? E raised to ln x is just x. This is the formula that I have used over here. Okay, so this is just going to be 1, and is 1:1 there? Yes, it is. Wow. Is that clear? Understood? Yeah, very interesting question. Beautiful question. So what was the question? The question was to find the activities ratio. Activity is lambda into n. So just substitute lambda's values and n's values in the form of exponent, and remember lambda and t half are inversely proportional to each other. So that is the end of the session, and again I want you guys to be in this leaderboard. I want you guys to be in these ranks this year, because I want 1,000 ranks from Enthuse. Already so many students have started the journey with Vedantu right from Enthuse by making my use of my coupon code right over here for joining the crash courses. The link is there in the description. These crash courses are for all the students who are probably done their coaching with some institute offline and online, or they want to level up their preparation, or they want to probably begin their journey from boards to JEE. No matter which state you are in, no matter which condition you are in, this solution of crash course is just for you. This is a complete full-fledged package of lectures, test series, assignments, mock tests with the best teachers you have. And this crash course is in English. That means you don't have to break your head. Oh my God, sir, I can't understand English. I can't understand Hindi. Don't worry. You can watch the recordings, everything. All you need to do is make sure you enter the description box of the video that you guys are just watching. Go below, and at the bottom you will see JEE crash course. Click on this link. Okay, you are class 12th, select your exam. If you are NEET student, select NEET. Okay, that will open up the NEET crash course. If you are a JEE student, oops, where did it go? Okay, I will just reopen this link. Yeah, select JEE 22 crash course. You will have 75 live classes, starts on 21st Feb. Don't have to worry. Even if you are watching this video now, you can rewatch those classes again. Doubt solving is also available after the class. Even during the class, there is a separate teacher who is solving all your doubts. Okay. Now, this timing is such that it ends well in advance before your first JEE mains attempt. and this is for 9,000 rupees with all the live interactions that you can get with PDFs, recordings, test series, analysis, report cards, assignments, doubt solving in the class, outside the class, all of this. And it says 9,000, but look at this magic. When you use my coupon code, you save 1,000 rupees and you get it for 8,000 bucks. It's hardly, 100 rupees and chiller per session. If you consider the test series and the assignments, it's even lesser than that. So it's a completely worthwhile crash course because you have the quality teachers, the best teachers with doubt solving. It's not just, there are many institutes who give you crash courses for 2,000 or even 1,000 rupees or even 3,000 rupees, and students get excited about it, but they are in a complete shock once they join the crash course because it's just recorded classes. And even if there are live classes, there is nobody to solve your doubt, and there are no proper systematic test series, rank predictions, comparison of your rank, report cards, assignments. It's all random. It's like somebody has just copy pasted all the problems from 10 multiple books and given it to you. This is not like that. This is a very systematic course. So go ahead, enroll yourself into this crash course because this will probably change your life and you will be in the leaderboard very soon. I'm really hoping to do that. Thank you so much, Divya. Thank you so much, Medula. Thank you so much, Aryan. What will be the schedule of the crash course, Aryan? The crash course will be in the evening, bacha. Okay, in the time which is best suited for all the students. That's what it is. Okay. All right. I'm so happy, Pawan. I'll be meeting you guys soon. Is modern physics easy as compared to other branches of physics in JEE? Yes, I would suggest so. It is of the level of fluid mechanics for sure. Okay. Bye bye, Karthikeyan. Have a great time. Muskan and Pawan, Vivian, Vignesh. Have a great time. Yes. So do not forget to like, share and subscribe to our channel and the video so that you get more awesome stuff at your doorstep without having to go anywhere. And stay tuned with me. And this was Shreyas here. Bye bye. Take care. Hasta la vista.